So I recently built my own 3D printer, and a number of people have asked me how a 3D printer works or how I built this one, and I thought the easiest way to answer the question would be to make a video that shows it off. I apologize for any jumpiness in this video. I'm shooting it with a tablet that turns out takes better movies than my camera does, but it's kind of hard for me to hold it steady. So I've been using 3D printing for about the past year to make things, but mostly using a 3D printing service. And I've been making things like jewelry, like this pendant and this ring are both made out of bronze-infused stainless steel, and then this earring is made in brass and then gold-plated. And this has been working out really well for me, but I decided recently that I'd really like to have my own 3D printer. It'd be really nice to be able to make prototypes for these and see them quickly, and be able to make pieces for projects I work on at home. I don't expect to be able to print things in this sort of quality, but being able to do it quickly would be very nice. So I built my own printer out of wood, and here it is. This basic design was inspired by the RepStrap Prusa i3 model. The RepStrap project is devoted to coming up with a printer that can 3D print more copies of itself. They haven't reached that goal yet entirely. So far their printers only work in plastic, so they can't print out things like motors or precision ground stainless steel shafts, but they do have designs where all the difficult mechanical bits like motor mounts can be 3D printed, and then you just add some standard components like the motors and hardware, and you can put the printer together just using hand tools, and that's pretty cool. But if you don't have a 3D printer in the first place, what do? Well, then you can pull yourself up by your bootstraps by building something that they call a RepStrap. And that's just essentially whatever printer you can make using whatever tools and skills and materials that you have on hand. And so this, I think, is an example of a RepStrap. I had access to hand tools and a bench vise, so I made most of it out of wood. So the core of the 3D printer, or at least this type of 3D printer, which prints in extruded plastic, is the printhead, which you see here. The black filament on the top is ABS plastic, and that's the material I'm printing in. Inside here there's a toothed wheel connected to this motor that grabs the ABS and pushes it down into this printhead, into the hot end here. And that has a heating element and a very fine hole at the end of a nozzle, so it can put out a very fine stream of plastic, which looks about like this. It's about 300 microns across, or 0.3 millimeters. So if we move our printhead around while it's extruding that plastic, we can lay down lines or beads of plastic, and then line by line, and then layered atop layer, we can build up a 3D object. So to move the printhead around, we have to be able to move it in all three axes, X, Y, and Z. So in this case, for the X-axis, left and right motion, the printhead is attached to this carriage here that rides on these two stainless steel rails. And you can see the construction technique I used for this. I've got blocks of wood that I drilled holes through and then pressed brass bushings into the end. And that allows them to slide. And so that left and right motion is driven by a belt and this stepper motor hanging out here on the left side of the printer. For up and down motion, Z-axis, that whole X-axis assembly rides up and down on two shafts of its own, one here at the left side of the printer and one on the right. And again, the same technique. We've got a wooden block here forming the base of it. That motion is driven by this threaded rod here, and there's one on the other side as well. There's a nut captured under this bracket here, held in place with big globs of hot glue, so that when the shaft turns, the nut stays stationary, or doesn't turn, and then this whole thing slides up and down. So both those threaded shafts are driven together by a belt drive up here, and a stepper motor at the back of the machine, which ensures that the two shafts always turn by the same amount, so that the whole thing moves up and down and stays level as it does so. For the Y-axis, forward and backward motion, we don't move the printhead, instead we move the bed. That slides forward and backward on two rails, and it's driven by a stepper motor here and a belt drive. All the motors are driven by some stepper motor drivers here, and underneath this board is an Arduino, and the Arduino handles all the low-level control of the motors. So it gets commands like, draw a line of plastic to this coordinate at this speed, and it figures out the timing of telling the stepper motors when to step and in what order, and it drives the stepper motor for the extruder at the right rate to lay down a bead of plastic the size that we're looking for. The high-level control is all done by the computer that the Arduino is attached to, and some software here. So that software will take like a CAD model or a 3D model of an object you want to print, slice it up into layers, and then for each layer figure out how to draw it. Like draw the outline of the shape line by line and then sort of fill in the inside, either solidly or not. And that's basically how the whole system works. I've got some power supplies over here. There's some other details like end stop switches here, which there's got to be one for each axis that tells the machine when it's reached the end of its travel, so it knows where it is, where it can find its home position. But that's basically how it works. So this definitely is a RepStrap in that I'm working on pulling myself up by my bootstraps. I don't know if it shows in the video very well, but this motor for the y-axis is actually wobbling around a bit as it turns one way and the other. The problem is the bracket that mounts it is mounted to this board, and it's not a very stiff board. So I've designed and I've built or had printed a bracket here that will replace this one, and will mount both to the base and to this vertical board here, and that should hopefully make this mount stiffer. Additionally, you may notice my print bed here has to be a nice flat surface, and it's mounted on top of this wooden board, which itself is mounted to the blocks under here that slide on the rails. And that wooden board isn't exactly level. It turns out it's hard to drill a hole in a straight line. So I'm also printing out these little carriages here that will replace the wooden blocks underneath. And so these are nice and square, and they have the holes in the end to mount the brass bushings. So I have one done already, and what I'm printing out right now is a second one. And so once those are done, I'll be able to replace all the components of the y-axis and hopefully have that be a bit more stiff, a bit more stable, and that'll get me higher quality prints. That wobbliness of the motor really does show up in the prints. You can see in lines that are surfaces that are done in the y direction, you can see a bit of waviness that comes from that axis being wobbly. So that should correct that. I'm also printing fairly slowly right now because the x-axis started jumping yesterday. I don't know exactly why, but I think something in this belt here got loose, or things aren't sliding cleanly on those x-axis rails. So after I get the y-axis replaced, I'm going to start working on replacing all the wooden bits of the x and z axes. And hopefully at the end I should be able to print at least twice as fast as this is going now. You can see as it prints, this would be another copy of this object when it's done. It's still doing the base part. It draws an outline of the shape first in each layer that's nice. It does that kind of slowly and very smoothly, so you have a nice outline of the piece. And in the inside, it's not bothering to fill it in solid. It's drawing these lines to provide a bit of structure inside, but it's not totally filling up the inside, just to save plastic. But the software is smart enough to know when it needs to fill in solidly, like you can see it's doing right here, where in a few more layers that's going to be a surface, so it's providing a solid base for that. So it's pretty cool. The software is pretty smart about stuff like that. When you put all that together, the mechanical, the electric and electronic, the computer, the software, there's a lot that goes into it. Thankfully, a lot of the complicated stuff like the software I don't have to do. I can just download. Put it all together and you get a 3D printer, and then you can make anything. And there you have it.